Hey guys, improper integrals. Alright, now I'm going to go straight to the point. I'm not going to do any funny things, so I'm just going to make you understand. I'll go straight to the point. So, improper integrals are you get questions like this. When you see an infinity in your limit area, when your limit is infinity, so it doesn't look nice, so you need to change it. So one of the things they do is they change this infinity to an unknown, so it makes it look nicer. So limit here, what you do is you do a limit b approaching, let's make this become b then, make this infinity become b, so b approaching infinity is what you need to do, and then you copy back your question, but you replace this infinity with a b, so 0. And then the other thing they do is they go to write this f dot dash. Yeah, just copy back your question then. Yep, get it? Get it? Okay, so then next, what we do, we integrate our function. Integrate our function is normal. Okay, copy back the first thing first. Copy back this one first. And who cares? Okay, so copy back this one first, and then what you get when you integrate f dash x, you get fx. Okay, and then you copy back your limits. So now you just do as your normal integration. You substitute this one inside and you substitute this one inside. Well, when you substitute b, notice that the b is approaching infinity, so your b will be equal to infinity. So take this b as an infinity and substitute it inside. So here's another important theory. Well, I think you guys can get this theory, right? Okay. Now the next theory. Okay. Now, what happens when you see that your root contains from negative infinity to infinity? Okay, the simple thing you need to do is to split these two things up. What do I mean by splitting these two things up is you write like this: from 0 to infinity, f dash x plus from negative infinity to 0, f dash x. Now, this is what you need to do. You see this one is quite similar to this question that we did before, right? So just do the same way. Put limit in front, b approaching infinity. What you get is the same thing. Please b become b, 0. Okay, f dash x. Well, this one is a little bit different because you're substituting this one. So we don't use b then, we use, let's say, at a approaching infinity. Negative infinity, sorry. Negative infinity because it's negative infinity. Okay, so here's a. So 0, f dash x. Okay, so next we just do our normal integration then. Limit b approaching yada yada, and then integrate this one yada b 0, and then you do this integration again yada. Remember, a is down there, a 0. So it's the same method as before. Use this one, substitute inside. Use this one, substitute inside. Your b is negative infinity. Well, this one is a little bit similar. Well, it's actually quite similar then. So you substitute your 0 inside minus your this value. A is equals to negative infinity. Well, the main point of this whole thing, this whole 8.7 thing is you need, whenever you see an infinity sign in your limit, please use this method. Just substitute your infinity with any unknown you like, b or a or whatever, x, whatever thing you want to do. Well, maybe not x, maybe an a. No, that's the perfect one. So that's the main thing about this chapter. So let's head on to the example and see what happens. Enjoy the example. Thank you.
Epic calculus time. First, go to the toilet. The female toilet. Open the cubicle door. Found a marker pen. Epic surprise face. Take the marker and run. And then run some more. Run back to your seat. Pause and sit down. Look at the question. Scold the question. Panic time. Look at the question again. Understand the question. Take the marker. Write limit b to infinity. Replace infinity with b and then write back your function. Copy back the limit and then integrate your function. Copy the limit again and then substitute b and 0 into the function. Oh yeah, this one equals to infinity. And therefore infinity minus 0 equals to infinity. Got the answer, time to celebrate. And then play FIFA. Hee hee!